Hey guys, welcome to the first video tutorial for Computino 5. This is just going to go out based off the lecture videos that I posted earlier, and it's going to be, as long as you understand the lecture video, I don't think you'll have a problem understanding this. So let's just get into this. So first question here I want to look at is just figuring out if these statements are propositions. So we know the definition of a proposition is a declarative statement that is either true or false, but not both. So let's look at the first one here. Who is the greatest hockey player of all time? Oh, I don't know. I don't know who is, but he should. This is not declaring who exactly is the greatest hockey player of all time. It's asking who it is. And the statement is neither true or false because it's not declaring a fact of any type, it's asking for a fact. So this is not a proposition. Alright, so next one is pasta as an Italian dish. So this is more of a declarative statement. It's saying that pasta is a dish that comes from Italy. And by dish I mean food if you're not into that lingo, you know. But this is a proposition because of the fact that it is declaring a fact, and it's also a true statement, so we can call this a proposition, yes. And then the final one is Top Gear is a British show, and by show I mean TV show. So and this is a true statement because it is a British TV show and it is declaring a fact. Top Gear is a British show, so it is a proposition. Alright, so fairly easy example there. Let's get a little bit more difficult stuff, but when I say more difficult, I just mean like it takes more work. It's not much more difficult in reality. So here we have the statement, we have a statement that says, let A be I play hockey every day, and let B be I am a good player. These are two propositions I declared, and here you can see I have two different logical formulas. So I'm just going to use these propositions to translate these formulas into actual English sentences. So let's just get started with the first one. Here we have A and not B. So we know that not is just going to be not in English, very easy. And now, and we know can also be written in English as and, or it can also be written as but. So we can use that. So let's write the first statement here because that's really easy. We just copy down what it says. I play hockey every day. Now in this case, it would make more sense to say but because it just sounds better. So I'm going to use but here. But I am. Now if there's a negation, so we have to say not a good player. So sad. Poor guy. Poor guy being me. Sorry. Oh, self. No. Okay. So now let's go into part B here. Now it's saying A implies B. So when you have an implication, we always use the words if, then. Or you could also use some other words that I went over in the video tutorial, but in this case, I'm just going to use if, then, because that's the one I like the most. So here we know A is just I play hockey every day. Then he's implying B, so I am a good player. So that's pretty easy. It's just saying here if he's a good player, or if he plays hockey every day, then he's a good player. So that's a very easy statement here, and we know that if these two statements are true, in an implication, if two statements are true, then the whole statement is true. So in this case, the whole implication will be a true statement. So that's nice. Alright. So let's move on to part 3 now. In part 3, I'm just going to do a lot of the same as the last part. So it's just use a little more complicated formulas here. So let's get started. So the first proposition here is let G be I have a good job. And then let F be I have a great family. And then let H be I am happy. So the first formula here is saying G or F implies H. So to write that out a little better, if G or F, then H. That's all it's saying. So let's add in the propositions here to make it a little easier to see, or just to complete the translation. So if I have a good job, or I have a great family, then I am happy. So he's just saying that if I have a good job or I have a great family, then I am happy. So, and we know with the or, both of these can be true to make the statement true. So if one is false, then the whole statement is true still. Both of them, if both of them are false, that's the only way you're going to get a false, and that'd be really sad in this guy's case. So let's move on to the next part here. So let's say, using these statements again, let's write out what this says. If G and not F, then not H. So we know that this is a really pretty simple translation here. If I have a good job, and I think in this case but would sound a little better again, so but I do not have a great family, then I am not happy. So that was a pretty like a very easy translation. So if he just doesn't have a good job and he doesn't have a great family, then he's not happy. So both of these need to be true for the first part of the statement to be true. So basically both G and not F have to be true for this statement to be true again. Alright, so let's go on to the last question, part 4. So I just have a few statements here, and for the first one, all I want to know is if the statement is true. So if 8 times 6 equals 54, then the sun is shining. So when we have the if and then statement here, we know that this is an implication. And we know for an implication, let's write out the truth table again. So if we have two propositions P and Q, then the implication from P on Q, with all our true and false possibilities written out here. So we know that when they're both true, this is true. But when P is true and Q is false, then this whole statement is false, and then the rest is true. So let's look at this here. So if 8 times 6 equals 54, so we know that 8 times 6, it doesn't equal 54. So then we have this statement here is false. But then the sun is shining. Let's say the sun is shining outside even though it's 11 at night. Let's say the sun is shining outside, so this is true. Well then, we have a false and a true, and in this case, this is a true statement. So we can write here, this is true. Alright. So now let's look at the next question here, part B. If I'm betting my money and playing games, then I am in a casino. So I just want to translate this into a logical equation. So first you have to identify what our propositions are. So I'm betting my money. That would be your first proposition here, because we can identify the words that are operators. We have if and then right here, and we also have a and. So we know our logical operators that we have to use are going to be an implication and an and. So what's our next proposition here? Playing games. I should have made that a better word or a better proposition. But let's just say for argument's sake that it's I am playing games. Then I am in a casino. So let's translate this into logic. So let's call betting money a B. Let's call playing games G. And I am in a casino C. So those are your three propositions written as variables. So let's write this out. If you have B and G, because you are betting and playing games, then you are at a casino. It's just as simple as that. Alright, so let's look at one more translation here. I am not a professional athlete because I do not get paid, but I play sports. So here we have I am not a professional athlete as our first statement. Now, as our first proposition, sorry. So this one's a little trickier because it seems to be that the result of the implication is right at the front of the statement. And having this because here, I don't think I included it in my lecture video, but because can also state an implication. This is basically just saying something I did include in my lecture video. If you have a P and a Q, one way of saying an implication in English is Q if P. So another way of saying this statement here is just using because. So we have our first thing here, I am not a professional athlete, and I do not get paid can be your next logical statement, or your next proposition, so I'm going to call that D. And then finally, I play sports can be S. So right now we know we have one logical operator as an implication, but we also have one more logical operator here, and that's the but. And we know that but can also mean and. So let's write this out. You have two statements here that are anded together. So first you have D and S. And then that implies P. But we also have two more logical operators, and they're both the same. We have two nots right here. I am not a professional athlete, and I do not get paid. So here at the front of the statement here, we have to write a not sign. And at the P, we also have to write a not sign. So that's a really quick tutorial video on propositions and then translating propositional formulas into logic, or into logical statements and vice versa. So thanks for watching, and we'll see you next week with whatever the hell we're learning.